The random variable z has a standard normal probability distribution. Find the probability that z is less than negative 2.14. All right, so remember z is the notation we typically use for a standard normal random variable. So we can assume it's got a bell-shaped distribution. Of course, it tells us that explicitly here, but usually in statistics, if you see z, they're indicating something that has a standard normal probability distribution. Okay, so the center of that curve is always at 0, and we're looking for the probability that z ends up being less than negative 2.14, so minus 2.14. So it's the probability a randomly chosen value here is less than negative 2.14. All right, so less than that is going to be shading to the left of that location, right? So remember, negative 2.14 is on the left side of the curve because we're looking for values that are less than that, right? Because the less than symbol that's here in our statement, that indicates we're shading to the left and we're looking for the area to the left of that point. All right, well, what's going to happen if we go to the z-chart and look up 2.14? We're going to get the area from here to the center, and that's not at all what we want. So we'll have to use that area to get what we want. Let's go get the area first, and then we'll talk about how to get what we want. So we're going to look up 2.14 now. All right, so we're going to scroll down until we see 2.1 first. All right, so here's the 2.1, and to get where we're at 2.14, the first number after that is 2.10, then 2.11, 2.12, 2.13, 2.14. So the answer is 0.4838. But remember, that goes here, 0.4838. So that's not the area we're looking for, right? Remember how the z-chart works. If you go to the top of the curve, you can see it gives you the area from the line you look up to the center. If you're on the left-hand side, it's from this line to the center. That's the idea. So what we found is an area that we're not interested in. We want the other area, right? But we do know that from here to here is half of the total area of the curve. It has to be 50% of the area because the standard normal probability distribution is symmetric about its mean. So half of the area is on the left, half of it's on the right. And that as a decimal, by the way, then is 0.5000. So all we have to do is to do a little subtraction. In other words, if we were to subtract this area from the 0.5, right? We end up with the area we're interested in. So just to save a little time, we'll just do 0.5 minus 0.4838 right here in the calculator. And then we're done. 0.0162 is our solution. Okay, so the answer is approximately 1.62%. Or as a decimal, you could just write it as 0.0162. And that's the area in the shaded tail of my drawing.